Hello everyone, my name is Adam Safran, and today I will be describing some of my efforts to try to understand consciousness using the free energy principle and active inference framework. Towards this end, I have recently proposed a synthetic model of consciousness that I call Integrated World Modeling Theory, or IWMT. Today I will describe some aspects of the theory, as well as mechanisms and computational principles which I believe to be important for consciousness as integrated world modeling. I'll also describe some ongoing explorations and directions for future work. The goal of integrated world modeling theory is to try to make headway on the enduring problems of consciousness. How are we to understand it? The method I used was to cross-reference existing theories, noting points of overlap and convergence, as well as differences. And I focus on the Global Neuronal Workspace Theory and Integrated Information Theory as the two most widely known theories of consciousness, and try to bring them together using the free energy principle and active inference framework, while also respecting their differences. In this integration attempt, I draw upon Ned Block's distinction between phenomenal and access consciousness. By phenomenal consciousness, I mean experience or subjectivity, or what it is like to be a system capable of generating experiences from a particular subjective viewpoint on a world. By access consciousness, I mean awareness or knowledge of experience, or the ability to manipulate and report on the contents of experience. In brief, integrated world modeling theory suggests that phenomenal consciousness is what it is like to be the functioning of a probabilistic generative model for the sensorium of an embodied embedded agent. Access consciousness, and possibly also basic phenomenal consciousness, require this information to be integrated into world models with spatial, temporal, and causal coherence for systems and their relationships with their environments. This distinction between phenomenal and access consciousness also becomes important for my attempt to bring together integrated information theory and the global neuronal workspace theory. Specifically, IIT focuses more on phenomenality, and GNWT focuses more on conscious access. However, I also suggest that computational principles from the global neuronal workspace theory are also relevant to understanding the processes that generate experience. And specifically, I argue that GNWT can be thought of as an architecture for engaging in discrete updating of deep beliefs, or an arena for Bayesian model selection to create an integrated world model. In the manuscript, IIT plays dual roles. One is as a general systems theory and model of causal emergence, where I explore correspondences between IIT and the free energy principle and active inference framework. In brief, I suggest that complexes with high degrees of integrated information are also Markov blanket bound systems with high degrees of model evidence. IIT enters once again in this synthesis as a model of consciousness, but differently, and there I explore ways that it can be reconciled to degrees with the global neuronal workspace theory. There's a sense in which the free energy principle and active inference framework already are a fair way towards explaining experience, where experience, or the stream of consciousness, is understood as the iterative generation of perceptual inferences. However, I'd say there's at least two outstanding issues, and one would be the Bayesian blur problem, and the other would be the boundary problem. The Bayesian blur problem is how or why is it that a probabilistic model of the world would be experienced in a discrete or particular way. That is, we don't experience a superposition of possibilities, or it doesn't seem like we're experiencing distributions over the variables of the world, but rather there are particular values, sufficient statistics. The boundary problem is, with respect to generative modeling, what aspects are in or out with respect to the processes that generate consciousness? Should we think of the entire generative unfolding of the organism and its relationship with its eco-niche as entailing consciousness in an extended mind sense? Or should it be something that stops at the boundaries of the nervous system? Or is it some sub-network that's particularly important for generating experience? And integrated world modeling theory argues for the latter. The Bayesian blur problem, whether it's a problem that can be a matter of opinion, I think Andy Clark and Wanja Weiss have already gone a long way towards dissolving that issue. However, I provide an additional set of factors that could be relevant. And so with respect to these issues, I propose that metastable, multi-scale, nested synchronous complexes integrate information from various modalities into a unified probabilistic model. These synchronous complexes, because they have particular temporal and spatial scales over which they form, would help to filter or determine degrees of inclusion or exclusion with respect to the generative processes involved in creating conscious experience or entailing. The idea would be that if there's this window where a metastable synchronous complex is forming, then this could potentially help to generate a more precise joint posterior, or potentially a maximal a posteriori estimate thereof. Along these lines, inspired by Selin Adesoy's connectome harmonic brain nodes framework, I describe synchronous complexes as self-organizing harmonic modes, or SOHMs, where the idea is that the formation of a synchronous complex computationally is entailing loopy message passing for the sake of approximate inference and marginalization over the subnetworks so synchronized. Among systems that could give rise to synchrony, different kinds of synchrony, I specifically focus on alpha frequencies and posterior cortices as being important for generating experience. Specifically, I focus on the posterior medial cortices as a source of the mind's eye, or the Cartesian theater, if you will. And I focus on the parietal cortices, and perhaps in particular the inferior parietal lobule, as a source of both body models or schemas and also attention schemas. And so if you bring together these medial visual generative processes with parietal lateral processes with respect to embodiment and awareness, or your attentional or intentional state, and have these all jointly bound together, I suggest at alpha frequencies, that this would give you the ability to generate the experience of a visual world with your organized according to an egocentric reference frame, with the feeling of your embodiment and your awareness as a feeling of your intentional attentional state, this all being as one field of experience. And I argue that this would be what gives rise to the what it is like. In terms of mechanistic and computational principles, I focus on variational autoencoders and describe ways in which these can be viewed as, where modifications of these can be viewed as having correspondences with predictive processing. Similar to Kanai's recent proposal, I describe how if you take a variational autoencoder and fold it over at its reduced dimensionality bottleneck, entailing a latent feature space, that this folded autoencoder, if the generative decoder is continuously explaining away the the inputs of the ascending stream of the encoding network, that this could be an account of predictive processing. And I further describe how synchronous complexes might be thought of as entailing a marginal message passing regime. And I try to go into some details in fleshing this out. I further try to describe how different autoencoding hierarchies, where each modality could be understood as either a hierarchy of autoencoders or itself one folded autoencoder, an autoencoder constituted by autoencoders, where each folded autoencoder from each hierarchy can be bound together. Their information can be integrated via loopy message passing, which I also describe in terms of turbo coding as a concept from telecommunications, which has been shown to approach the Shannon limit for sending data over noisy channels. But the idea would be that this connection of different autoencoding hierarchies, particularly at their bottleneck portions, would help to give you cross-modal priors and would specifically, though, take these bottlenecks and create a shared latent space across them, a shared model for an autoencoding hierarchy. I further suggest that these latent spaces might be structured according to principles that might be well describable in terms of principles from graph neuronal networks, which are having increased interest because of their capacity for very efficiently modeling a wide range of phenomena and being useful for data fusion and synthesis. But in this case, the shared latent space, which is instantiated by this synchronous activity, which I'm suggesting entails loopy message passing for approximate inference or turbo coding, creates, if it's over the right subnetworks, a unified field of experience where consciousness is the shared latent space, allowing for inferential and functional synergy, potentially an integrated world model. So I'm currently trying to explore how different aspects of neural functioning might be understood in terms of these machine learning principles, where sensory modalities or the sensorium could be thought of as an autoencoding hierarchy, and where other aspects like metacognition might be understood in terms of things like generative adversarial networks, and where some aspects of action selection might be potentially well modelable in terms of things like reservoir computing and liquid state machines. One of the places I'm particularly focusing right now is in terms of the ways that the hippocampal system might be able to take autoencoding hierarchies as they generate these estimates of your sensorium, that you might take these estimates and these iterative estimates and organize them according to 2D spatial temporal trajectories, either through physical space that the organism encounters as a whole, or potentially through abstract spaces. And so in this way, I'm trying to describe how the hippocampal system might play a particularly important role in allowing for episodic memory and episodic imagination. With respect to this, I'm also wondering whether the ability of the hippocampal system might be able to orchestrate contrasting between sensed and imagined states in a way that could contribute to intentional, goal-oriented behavior and agency, understood in terms of a kind of back-chaining from goal states, which might also be describable as a kind of Markov chain Monte Carlo search process through policy space. And finally, I'm trying to further describe correspondences between integrated information theory and the free energy principle, with synchronous complexes potentially providing bridging principles. So that's what I'm working on at the moment. I would very much like to discuss this with anyone who's interested. Thank you for your time and attention.